Are you ready? I did, thank you. So multiplication properties, okay? You have done several properties. This is why you're in the front, because you want to do things like that instead of pay attention to math. You have done several properties already with exponents, okay? Today you're going to learn a new property that I feel like often gets confused with a different property that you already know. So I need you to really think through what's different today and why are we doing it differently. So the property that I'm talking about is this one, raising a power to a power, okay? The one it gets confused with is this one. So here's what I need you to see. This has two different bases, but they're the same base, right? A to the fifth times a to the second becomes what? A to the seventh. Okay, so when you have the same base and you are multiplying, you add your exponents. But when you have one base taken to a power and then you take it to another power, it's different. It's like this. It's like saying 5 to the fourth times itself. Then you're adding, right? If it looks like this, we would add. If it looks like this, we do what? Multiply. Okay? So this new property says if you take a power to a power, you multiply your powers. If you take a power times a number to a power, then you add them, okay? So if I have, let's just look at this one, n to the fourth, and I'm taking that to the seventh power, that is this, n to the fourth times 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 n to the fourth. Do you want to write that out 7 times? No, that's annoying. So instead, what happens is you multiply these, and you get what? 28. N to the 28th power, okay? Look at B. X to the 2/3 to the 1/2. What are you going to do with 2/3 and 1/2? You're going to multiply them. So you're going to go 2/3 times 1/2 and get x to some power. When you multiply fractions, what do? Do you need a common denominator right now? No. When you multiply fractions, you go straight across. So we're going to go 2 times 1 is 2. 3 times 2 is 6. So x to the 2/6 power is the answer. It's just not the best answer. What's the best answer? 1/3. So call it x to the 1/3 power. Okay, look at C and D. P to the 5th to the 4th power and P to the 4th to the 5th power. Think about what that means. This is like P to the 5th times P to the 5th times P to the 5th times P to the 5th, right? That's P to the 5th to the 4th power. If that helps you to think about it that way, great. You are welcome to write that down. Then you would do what with all these 5s? You would add them together. If you are thinking through it that way, you're adding them. But the little shortcut that we get to take is if you're taking that power to a power, you get to do what with it? You get to multiply them. Notice you'll get the same answer either way, so I really don't care which way you do. I recommend you multiply because it's going to simplify your life a lot. But if for some reason that is tricky to you, you could write it out. So what is P to the 4th to the 5th power? P to the 20th. It's the same answer, okay? You're still multiplying. P to the 20th power. Khalees.
Is there any way do a fraction that no longer to the simplest form?
Does your calculator leave it as a fraction? It probably turns it into a decimal, right?
It leaves it as a fraction, but it goes to the simplest form.
Oh, you want it not to do that? Probably not. Not that I know of. Yeah. Okay, letter E. What do you get? P to the 1/8. So be careful. We are multiplying these things. 1/2 times 1/4 is 1/8. So p to the 1/8. Okay, now we're going to take that concept and we're going to throw in some negatives. Tell me about negative exponents. What do they do? It moves things, yeah. So if it's up top and it's a negative, we're going to move it down below and make it positive. If it's on the bottom and it's negative, we're going to move it up and we're going to make it positive, okay? You should never give me an answer that has a negative exponent. The one exception is scientific notation. That is the only exception. It's the only place you should have a negative exponent in your answer, okay? Let's take a look. Think about this for me. PEMDAS says you do what first? Parentheses. There's nothing to do inside of parentheses right now, right? It's just y to the 5/2. There's nothing you can simplify there. So we don't have to worry about that. Then E is the exponents. We have to do our exponents before multiplying and dividing, okay? So before we multiply these, we have to do this, because the only thing that -2 is attached to is that second y. That's what these parentheses are telling you. Now, you've got options with this. If you want, you could multiply this by -2 and then move things. Your other option is you could do what first? Anybody know? You could move it first and then multiply. Out of curiosity, I'm going to show you both, but I want you to evaluate which one you like better, okay? And then I'm going to ask you to tell me which one you like better. You could either, right now, call this y to the -10/2, and then turn that into 1 over y to the 10/2. -10/2, you could technically call that -5 right now, so then this is a +5, okay? So you could do that, where you distribute that -2 first, multiply it, and then move it. Your other option is you do 1 over y to the 5/2 squared, and then take that squared and call it 1 over y to the 10/2, which is 1 over y to the 5th, okay? So either you are moving it first and then dealing with multiplying, or you're multiplying first and then dealing with moving it. Who likes to move it first? Who likes this way better? Four and a half of you. Okay. Who likes this way better, where you multiply first and then move? It's like 4.5 of you. Great. That's not helpful, you guys. I don't know who's to go with then. I'll try and do it both ways, okay? I'll try to show you, not on every single problem, but I'll try to show you as much as I can. Okay, so we moved it and we got 1 over y to the 5th. Is that our answer? What's missing? That y to the 3rd out in front. So you have y to the 3rd and 1 over y to the 5th. Here's why, if you don't move it first, maybe it seems a little easier to some. This is, if we multiply across, y to the 3rd over y to the 5th. Do you remember what we said we do when we divide? What do you do with your exponents? What? Subtract? Did we do that? We did that, right? We subtracted exponents? We haven't done the division yet. We haven't done division. We haven't done division yet. Never mind. Let's do it the other way then. Let's do this. So you have y to the 3rd and y to the -5th, right? That's what this was before we flip it. What do you do with your 3 and -5? Add them together. This is y to the -2nd power. That becomes 1 positive, no, -2nd.
But I thought we were at y to the.
Okay, Rewind. I was thinking, sorry, I just did this with my algebra 2. So I was thinking through what they've done already and you guys haven't done it yet. My bad. This is all one problem. Do you love it?
Yeah.
Mm-hmm. Okay, here's how we're gonna do this. Yes. I mean, you can leave what you have. I'm just giving you a clean slate. Y to the negative 5th over 2, I'm gonna multiply that, okay? We're gonna multiply. Y to the negative 10 over 2. You still have that y to the 3rd out in front. What's negative 10 over 2? Negative 5. So this is y to the 3rd times y to the negative 5th. What do you do when you have the same base and exponents? Add them together. So 3 plus negative 5 is y to the negative 2nd. What do you do with y to the negative 2nd? You flip it. You're going to bring that down. So 1 over y to the positive 2nd. Is that better? Okay. Letter B. This is x squared and then x to the 6th to the negative 4th. What is being taken to the negative 4th power right now? The whole thing? Just the x to the 6th. Okay. So a power to the 6th to the negative 4th means you can do what with those two numbers, 6 and negative 4? Multiply them. So this is x squared times x to the negative 24th. What can you do with the 2 and the negative 24? Add them. So x to the 2 plus negative 24 is x to the negative 22nd. How do you get rid of the negative exponent? You flip it. So it's going to be 1 over x to the positive 22nd. Is that better? You like that better? Yeah? Okay. You try C, and if you finish C, try D also. But I just want to see how this is going. Letter C. What did you do first? Right. Multiply these together. 5/3 times 3 is w to the 5th power, right? And if you don't like fractions and multiplying, plug the fractions into your calculator. 5/3 times 3. If you plug that into your calculator, guess what it's going to tell you? 5. Look at that. So you have w to the negative 2nd times w to the 5th. What do you do with your negative 2 and your 5? Let's not move it down yet. You can, but apparently I have not taught you that yet. Add them together. Negative 2 plus 5, right? W to the negative 2 plus 5 is w to the 3rd power, and you're done. Okay? Okay, go to D. This is a power to a power, so we multiply. S to the negative 5 times a negative a half is a positive 5 halves. Now, if you plug into your calculator negative 5 times negative 1/2, it's going to tell you 2.5. There is a button on your calculator that will turn it back into a fraction for you. Did you know that? No. S to D, it's something like this. Okay? It'll turn it back into a fraction if you don't know how to make that a fraction yourself. But here's the deal. Negative 5 and negative 1/2 is a positive 5 over 2. Okay? So S to the 5 halves and S to the 3 halves. What do you do with 5 halves and 3 halves? Add it together. S to the 8 halves. What is 8 halves?
4.
It's 4. S to the 4th power. Okay? Questions on that? Okay, do you see how we're combining the adding of exponents and the multiplying of exponents? It is super important that you keep it straight. When do you multiply them and when do you add them? Okay? Okay. This next one is very similar, but now instead of just one thing brought to a power, it's taking a product of things to a power. So it's kind of like the distributive property. What happens is if I have AB to the nth power, I take that n to both parts. So it's a to the n and then b to the n. okay? So if it's 3x to the fourth power, I take 3 to the fourth power, which is 81. You can plug that into your calculator. I don't expect you to know 3 to the fourth power off the top of your head. And then x to the fourth power, x to the fourth. So 81 x to the fourth, okay? Okay, so take a look at this first one. It says write an expression for the area of the square. Can anyone tell me how you find the area of a square? All of the sides? Like 4 sides multiplied? 2 of the sides, right? Area is base times height or length times width. So if this is 5x cubed and 5x cubed, we're taking 5x cubed and doing what to it? What power? We're squaring it because you're multiplying something by itself, right? So 5x to the third to the second power is what you're really solving for right now. What do you do? Which exponent? Right, but how do I simplify that? We're not adding them. What we're doing is we're taking this to the second power, so 5 to the second, and we're taking this to the second power. Do I add these or multiply the 3 and 2? A power to a power, you multiply, okay? So this is going to be x to the 6th power. What's 5 squared? 25. So 25x to the 6th power would be the expression for the area of that square. You don't have a water bottle. Bummer. Questions on that? Okay, let's try it on this one then. 7m to the 9th to the 3rd power. What is being taken to the 3rd power right now? All of it, right? Everything is, because it's all in parentheses. So you're taking 7 to the 3rd power, and you're taking m to the 9th to the 3rd power. So 7 to the 3rd, again, plug it into your calculator. I do not expect you to know these off the top of your head, but 7 to the 3rd power is 343. Everyone know how to plug that into your calculator? You hit 7, and then there's that caret button, and then 3, and hit enter. 7, caret 3, enter, okay? So that's 343. What is m to the 9th to the 3rd? The 27th. It's m to the 27th power. So 343 m to the 27th power, and that's your answer. Okay? Take them both, take all parts to that power. All right, letter B. 343 m to the 27th. All right, what happens when you take something to a negative power? You move it. So right now it's a numerator, so we're going to make it a denominator, 2z to what power? The positive 4th power. Okay, we take the negative away, but that's all that changes. Put the 1 on top.
Why do you not multiply 4 and 2?
We will, but just we haven't yet. We won't. We'll take it to that power. Okay, so this 4 has to go to both these things. And can I just tell you, my Algebra 2 students literally just did this last chapter. Theirs get fancier. You guys get a simpler version of it. But here's what always ends up happening on this. And I'm going to tell you the wrong way so that you avoid it. Okay? This is not 1 over 8 z to the 4th. Why not? It's an exponent, right? You multiply the numbers, 1 times 4 for the variable. You do not go 2 times 4. 2 is a number taken to a power. What is 2 to the 4th power? 16. So 2 to the 4th and z to the 4th, which you can simplify to 1 over 16 z to the 4th. Does that make sense? We are not going to multiply the 2 and the 4. We're going to take the 2 to the 4th power. Okay? Take it to a power. Okay, letter C. You know what? You try that one. Very similar to the last one. See what you get. So here's what you're doing. You have this whole thing taken to a negative power. What do you have to do with that negative power? You're going to put a 1 over it and make it positive now, okay? So this becomes 1 over, it's identical, 3g to the 4th. The only difference is now your exponent isn't a negative. Now you can take the powers. So now you can go 3 squared is 9. Okay, so on top we still have a 1. 3 squared is 9. It is not 6. You don't go 3 times 2, right? You take 3 to a power. 3 to the second power is 9. G to what power? What do you do with these? Multiply them, right? 4 times 2 is 8. So 1 over 9 g to the 8th. Good? Tell me not. If it's not, I'll try to explain it a different way. Okay. Look at this one. N to the 1/2 to the 10th. What do you do? Multiply. 1/2 times 10 is 5. So n to the 5th power. Okay. What's being taken to the 3rd power right now? The 4. The whole thing. The m and the n. Okay. All of it. So 4 to the 3rd is not 12. That's the thing that a lot of people want to do, though. I'm glad you said that. We're not multiplying it, right? We're taking it to a power. So plug into your calculator 4 to the 3rd, okay? M to the 3rd. And then it's n to the negative 2/3 to the 3rd is n to the negative 2nd power. You can just plug into your calculator negative 2/3 times 3. It's a negative 2, okay? So look at what you have. You have all of this right now. What can you do with those n's? How? You can add them together. So 5 plus negative 2 is 3. So n to the 3rd, m to the 3rd. Did anyone plug in 4 to the 3rd? 64. I'm going to put that out in front. We always put the number out in front. I typically put it in alphabetical order, so I would probably write it 64 m to the 3rd, n to the 3rd, but either one of those is just fine. Okay. Okay. That's the answer. Okay, look at letter E. What is being taken to the 2nd power right now? Just x to the negative 2nd, right? So this is a power to a power. What do you do with a power to a power? You multiply. So this is x to what power? The negative 4th, okay? Don't move it yet. Just leave it like that. What do I do with this 3? Yeah. Take it to the 4th power. We're going to go like this. Okay? 3 to the 4th power. What do you do with the x? Take it to the 4th power. X to the 4th. What do you do with the y to the 5th? You multiply the 5 and 4. You take it to the 4th power, right? A power to a power, you multiply. Y to the 20th. So you have all of this right now. What can be simplified about that? The x's. So x to the negative 4th times x to the 4th is x to what power? 0. What is x to the 0 power? It's 1. Okay, anything to the 0 power is 1. So that's essentially just going to go away. You don't need to write a 1 in because when you multiply by 1, it doesn't change anything. What is this? 3 to the 4th. It is 81. It is not 12, right? Don't multiply them. Take it to the power. So 81. So that's taken care of. Our x's are taken care of. Y to the 20th. Is there anything else that you can simplify? We're not adding, we're multiplying. So when you multiply 81 times 1, it doesn't change anything, right? So then your answer is just that. 81 y to the 20th. fun stuff. Okay, look at F. Tell me what you'll do first.
Take the 3 to the 4th.
3 to the 4th power. So we're going to distribute this 4 here. So 3 to the 4th. Then what?
Take 5 halves.
Multiply C to the 5 halves times the 4th. So 5 halves times 4 is C to the 20 over 2, which is 10. Okay, so C to the 10th power. I'll write that down in a minute. What do you do here?
2 plus 3, or 2 times 3?
2 times 3. Okay, 2 times 3 is 6. So C to the 6th. So 3 to the 4th is what? 81. This is C to the 10th and C to the 6th. What do you do with the 10 and the 6? Add them together, okay? When they have the same base, you add them. So 81 C to the 16th. 20 divided by 2. So I went 5 halves times 4. So if you treat that like 4 over 1, 5 times 4 is 20. 2 times 1 is 2. So 20 over 2 becomes 10. Which again, you can plug into your calculator if you want. 5 divided by 2 times 4, if you want to multiply those exponents. Okay, last one. It is tempting right now, maybe not, to go 6 times 5, but you can't. Why can't you multiply 6 and 5 right now? Because PEMDAS says exponents come before multiplication, right? You would go 6, here, let's just start here. 6 to the 3rd, okay? A to the 3rd, B to the 3rd, times what? 5 squared, A to the -6th. Okay, so you're here. Think about what is combinable here. Are you allowed to multiply 6 to the 3rd and 5 to the 2nd? You can plug it in. 6 to the 3rd times 5 to the 2nd. It will multiply that for you. 6 to the 3rd is 216. 5 to the 2nd is 25. So you can do it that way, but you literally can just plug it in. 6 to the 3rd times 5 to the 2nd, and it does that. 216 times 25 is 5,400. Okay, so you're multiplying those. What does your A become? A to the 3rd and A to the 6th. You're going to add those together. A to the -6th is A to the -3rd. And then you have a B to the 3rd. Are we done? No negatives, right? So it's going to be 5,400 B to the 3rd over, move that A to the -3rd down and make it positive, and you're done.